Stars. The first thing that comes to your mind will be this. When you look at the sky at night, the stars all look alike, except some are brighter, some fainter, some are bigger, some smaller. Star is actually a ball of gas that releases energy, and it's held together by its own gravity and thermal pressure, and is born as the darkest, coolest cloud of gas. According to the Big Bang theory, matters are created by the massive explosion. As it gets cooler, interstellar medium is formed. It consists of about 70% of hydrogen molecules and 28% of helium molecules. They gather to form a huge gas of cloud called nebula, and the cloud starts to collapse towards the center of the cloud. When the gravitational force is massive enough to overcome the pressure against it, then it gets denser and denser, hotter and hotter. And eventually temperature and pressure in the core are high enough to ignite hydrogen fusion, and the star, like our sun, is born. If you look through the telescopes, you will see that the stars are all different in colors. Some white, some red, some orange, or even some blue. This has become a mystery for a long time until a famous physicist, Max Planck, solved the puzzle. He showed that stars emit different colors of light based on their temperature. Low-mass stars fuse hydrogen slowly, so they give off more red light and have less energy, while high-mass stars fuse hydrogens quickly, so they emit more blue light and have more energy, and therefore they appear blue, and low-mass stars appear red. Together with the spectrum measured from the surface of the star, they can be classified into different categories. They are O, B, A, F, G, K, and M. This classification is useful to study the relationship between the luminosity and the surface temperature of the stars. Hertzsprung and Russell plotted a graph of the luminosity and the surface temperature of the stars in the galaxy, and they found some patterns. The middle straight line is the main sequence stars, which burn hydrogen as fuel. The top is giants and supergiants, and the bottom is white dwarfs. This HR diagram is very important because it predicts how stars live their lives. After billions of years, hydrogen fuel may be exhausted. This will be the beginning of the dying of the stars, but high-mass stars and low-mass stars lead different afterlives. Low-mass stars may start to fuse helium in the core, while the atmosphere expands to become red giant. As the atmosphere gets further and further away from the core, the star loses control of its outer layer. Then it drifts off out into the space and forms planetary nebula. What left behind after the end of the helium fusion is a very dense white dwarf at the center of the planetary nebula. But more massive stars are different. They will continue to fuse carbon until iron, and they may become blue giant depending on their mass. At the end of a massive star's life is a devastating Type 2 supernova. The remnant of this powerful explosion is a neutron star or a black hole. The planetary nebula and elements ejected from the supernova will become the birthplace of other stars in the future, and the life cycle repeats. The core of a star is an element factory. Only hydrogen and helium were created during the Big Bang. All the other elements up to iron were created in the core of a star. But where do other heavier elements like gold, silver, lead, uranium come from? Well, they are formed during the supernova, where all the elements are flung out into the universe as clouds of gas and dust, and then these elements form other stars, planets, and ultimately us. The planets we are standing on, the iron in our blood, the calcium in our bones, the carbon in our cells, were created billions of years ago in the core of a star. We are all made from star stuffs. So understanding the universe is getting more and more important because knowing the birth of the universe is equivalent to understanding what makes you, you. Thanks for watching.